Hello, my name is Jessica, and today I'm here to explain you a problem about work. In this problem, we have that a person pushes a desk at 8 meters ramp to a platform situated 1.5 meters from the ground. If he applies a force of 180 newtons, what's the work developed? Now, in data, we have a unknown work, a force of 180 newtons, a distance of 8 meters, and the angle. To solve this problem, we have to use the work formula, which is work equals distance times the cosine of the angle times the force. We have the cosine of the angle. So first we have to find it. For this, we have a triangle that is 8 meters on the hypotenuse and 1.5 the opposite side. So this, we have to find the sine. Now, to find the angle, we have the arcsine of 1.5 equals 10.81. Now that we have all the values, we just have to put them on the formula, which is work equals 8 meters, which is the distance, times the cosine of the angle, which is 1081, times the force, that in this case is 180 newtons. Now, if we multiply them, we have that our work equals 1,419.51 joules. And that's the result for this problem.
Okay, so for this problem we have 4 points A, B, C, and D, and we have it all at different heights. We have to find the velocity of B, of C, and of D, and we only have the initial velocity of A, which is 0. Now first, let's write down the formula. Kinetic energy plus potential energy is equal to mechanical energy. Now kinetic, it's mass times velocity squared over 2, and potential, it's mass times gravity times height. Then we'll find the velocity of B first, and we will use points A and B. We will state that the mechanical energy of A is equal to the mechanical energy of B. Now, since we don't have the mass for this problem, we have to multiply all of our formula with M, and that way we can just cancel it out. And we just can continue with our problem. Okay, so the mechanical energy of A, which is mass velocity squared over 2 plus mass gravity and height of A, it's equal to the mass velocity squared over 2 of B plus the mass gravity and height of B. And now we just eliminate all the m's that there are in a formula. And now we have a new formula, which is the one that we are going to use now, that it's velocity squared of A over 2 plus gravity and height of 8 is equal to the velocity squared of B over 2 plus gravity and height of B. Now we have to substitute the values. First, gravity. Remember that Earth's gravity is always 9.8, so we only have to substitute that. Then it's multiplied by the height. In the case of A, it's 35 meters, as you can see in the problem. And then the velocity, as we said, it's 0. So it's 0 squared over 2, which eventually will also cancel. And then 9.8 again, because gravity is always 9.8, times the height of B, which is 20, plus velocity squared of B over 2. Since we don't have the velocity of B yet, which is the one that we're trying to find, we just leave it like that. Now we multiply 9.8 times 35, and the result is 343. Then 9.8 times 20, and the result is 196 plus velocity squared over 2. Now we have to isolate the variable, which is b. First, we put 343 minus 196, which is 197, which then we will multiply by 2 and then get the square root of that result. So we can isolate totally b. And then we have the velocity of b, which is 7 square root of 6, or in decimals is 17.146. So we already have that result. Now we have to repeat this process twice, now using the points B and C and then the points C and D. It's actually very easy, don't you worry, it seems very confusing. Then that is how we get the velocity of B, C, and D. And that's it.